Welcome to a lesson with Dr. Powell. Let's take a look at this series and think about doing an asymptotic inequality um, to show that whether this converges or diverges. Now, automatically, I kind of see an e to the negative n. That's exponential to k multiplied by this polynomial fraction. I'm guessing this will probably win out, and so it'll converge. So the goal will be to find something that's less than this. So let's try that. In fact, this part right here looks like it'll kind of go to n. Will that converge or diverge? Well, let's just see. I mean, we can kind of think of this as maybe the integral is easier to look at because we can compare it to this integral and integrate this. We can use integration by parts here. X1 e to the negative x, negative e to the negative x, and kind of look and see what's okay, we can even go down to 0 and get that. So we end up getting something like this. So we end up getting negative x e to the negative x. That's a plus and a minus. Okay, so minus e to the negative x. Okay, and this is from 5, and then a limit as x goes off to infinity. So as x goes to infinity, okay, well, this portion right here is like x over e to the x, maybe L'Hopital's rules in order. That has the same limit as take the derivative of the top is 1, derivative of the bottom is e to the x, and as x goes up to infinity, that seems to go to 0. So as x goes to infinity, this goes to 0, and this will also go to 0 as well. So, and then we're just plugging 5 in here. Yep, it looks like it converges. So we know, so that's good. So we know if we can compare it to this effectively, some constant multiple of this asymptotically, and so that it's less than, then we would know that we'd have convergence. Okay, so let's go ahead and see if we can make that asymptotic inequality and establish it. Okay, so, well, in order to do that, let's just keep the e to the n, negative n out separate, and then think right here what's going on. A polynomial thing that's, so we want something, so on the top, something smaller than that, I mean, or something bigger than it, so we could just double the n squared, right? Okay, so we can double the n squared, so that's bigger than the top. Then on the bottom, we want something smaller than it, so we could go over 1/2 times n, so a half of n, because that'll eventually be smaller asymptotically. So this thing should eventually be bigger than that thing right there. So then in this case, there are 4 halves in 2 divided by half if you like, or multiply both sides by 2, whatever. You get 4 as your constant there. So this will become, and this ends cancel, so you end up getting 4n e to the negative n. And then we knew this converged because that converged multiplied by 4, it still converges. When we throw it into an integral, hence it'll also work when we have a series. Therefore, since this converges, then this series converges, and it converges absolutely. And we're good. Thanks for watching.